The City of Brawley's Cross-Connection Control Program requires the installation of backflow prevention assembly devices for industrial, commercial, and some residential customers. The purpose of these requirements is to prevent the pollution or contamination of the city's water supply. Annual testing is required for assembly devices connected to the city's water distribution system by certified and approved backflow testers. This testing is required pursuant to the California Code of Regulations, Title 17, Section 7584, as well as the Federal Safe Drinking Water Act. In accordance with these laws and the city's ordinance regulating cross-connection control, the City of Brawley is responsible for preventing the degradation of the city's water supply. The City of Brawley supplies water to the water distribution network using large pumps that pressurize the water system between 50 and 70 pounds per square inch, or PSI. Backflow is the undesirable reversive flow of water or other substance into the drinking water distribution system. There are two ways that backflow occurs: back siphonage and back pressure. Back siphonage is a reduction in system pressure, which causes a subatmospheric pressure or vacuum to exist in the water system, allowing substances to flow backwards into the water distribution system. Back pressure is a pressure greater than the water system, which forces fluids to flow backwards into the water distribution system. The City of Brawley has constructed a model that demonstrates these two types of backflow and why this phenomena is a serious concern for the city in maintaining safe drinking water. First, we will show you how back siphonage from a commercial property can cause contamination at the customer's water tap connection. Here we have an example we see on a regular basis. A hose is connected to an outside tap, but in this instance, the hose pipe has been left connected in a vat of contaminated chemicals. We have a water tower at the top of the hill, and a water distribution main that feeds the fertilizer company, producing factory, and residents of the local town living down the road. The fertilizer chemical company has been going through modernization over the last few weeks and changed many of their processes since their last city regulatory inspection, but unfortunately failed to notify the City of Brawley. The chemical fertilizer company are in full production of their latest fertilizing chemical, which is toxic. The hose pipe has been left filling the chemical vat, as water is used to mix the chemical prior to bottling and distribution of the product. They think they're being clever by stopping splashes, but in reality they are posing a serious risk to our water quality. Everything in the network is flowing normally when suddenly a burst occurs in the water distribution network. One of our customers from the area goes to get a drink of water from their water tap, but notices there's a strange red color to the water. As they run the tap, the color gets stronger and stronger, so they call the city to inform them of the water quality issue. The city's Public Works Department front desk contacts the Water Distribution Division, who sends a water distribution operator to investigate the situation. In this example, we are lucky because there is only one factory in the area, so the inspector heads straight to the fertilizer chemical works. However, in a real-life situation, it can take longer to highlight where the contamination is coming from. The city inspector immediately identifies that a hose pipe is sitting in the storage system, and this has allowed for the contamination. They inform the chemical company that the contamination is preventable by the use of a reduced pressure backflow prevention assembly, or backflow device. With a backflow device, the chemical would have been stopped from back siphoning and contaminating the drinking water supply. The burst main is repaired, and the city has its water supply restored. However, the network is still needing to be flushed to ensure all traces of the chemical is removed, and sometimes the main has to be disinfected as well before the water is considered safe to drink again. As a city, this is very expensive in the form of work hours, precious drinking water wasted, and generates unwanted state oversight and media interest. Most importantly, it is a huge inconvenience to our customers, as they may not have access to drinking water during the decontamination process and may need to boil water or use bottled water for their household and business needs. Now we'll show you how a pump can have a higher back pressure than the water main and cause contamination to our city's water distribution network. A local homeowner owns a property that has Imperial Irrigation District, or IID, canal water supply. They are very proud of this water supply because access to IID water means they can irrigate the property's grass and trees with raw canal water, which is much cheaper. The homeowner uses a water pump to power sprinkler heads on the large property. The homeowner also has access to clean city drinking water and plumbs a line to allow him to pump IID water or city water into the irrigation sprinkler system. And suddenly, one day, the pump breaks. The owner is now very glad that he decided to keep the city water supply connected to the irrigation system. The The city's water line is pressurized at 60 pounds per square inch, or PSI, and it can still provide water to his large lawn and trees through a temporary cross connection to the city's water supply, which will power the sprinkler heads. The owner calls out a pump specialist to repair the pump, and the company gets there in record time to repair the pump. The irrigation pump remains connected to raw IID water and begins to pressurize the irrigation lines on the property. However, the homeowner is in a hurry and forgets to turn off his connection to city water supply. Due to the pressure that the pump is working at, the IID water slowly starts to pump back into the city's water distribution network and up to the water tower. In the city's water treatment plant control room, alarms are going off, and the SCADA system is showing that the tower has started to fill without any work being carried out by the city operators. The on-site operator goes and starts taking samples from the water tower, where they immediately notice something is wrong. The water has a green color and fails on water quality checks for chlorine. They then isolate the water tower supply and escalate their concerns to the water treatment plant chief operator. Water distribution operators are called again, and while carrying out their investigation, they visit the homeowners who have access to IID canal water. They find one homeowner that does not have a backflow device. They also find a cross connection between the drinking water and the IID water. The inspector requires the homeowner to disconnect the cross connection and install a storage system with an air gap, or place a reduced pressure backflow prevention device at the home's point of connection to city water supply. Again, this example has cost implication on us as a city, has a detrimental effect on the quality of the water in the network, and as such, all customers in the area are caused an unnecessary inconvenience.